The James Webb Telescope does many things, and one of its jobs is to search for potential life in the universe. And this guy right here thinks that it just found it.
Nikku Madhusudhan, who's the Professor of Astrophysics and Exoplanetary Science at the University of Cambridge.
He believes a planet 120 light years away, called K2-18b, may contain life. And I'm not talking about life existing at one point on this planet and is now since long gone. He thinks that life exists there right now. Now, we've heard this story before for decades at this point, that life exists somewhere outside of our planet, whether it's little green aliens, potential evidence for fossilized civilizations on Mars, and even more recently, potential alien life hiding in oceans miles beneath sheets of ice on moons in our own solar system. But this discovery on K2-18b feels different. Even Professor Nikku Madhusudhan himself was so shocked by the findings, he didn't believe them at first.
Well, it took me about a week to muster the courage to even think that that's anywhere close to real and break it to my own group, my own students working with me. So you don't drink anyone, you're just shell-shocked for a while.
The data received from the James Webb Telescope shows something that we've only found here on Earth, something that we've only ever seen produced by life. Headlines exploded, many jumping to confirm that life definitively exists somewhere else in the universe, while other scientists within his field reacted with strong skepticism. So let's explore these findings and uncover if the JWST data and Professor Nikku are correct, or if this is another example of a scientist misrepresenting results to fit their conclusion. Have we actually found alien life, or is this yet again another dead end in our endless efforts to find out if we're alone in the universe? This is an artist's rendition of an Haitian planet, an entire world covered in liquid water without land masses or terrain, a true water world. Its atmosphere is made up primarily of hydrogen, so the name Haitian comes from combining the words hydrogen and ocean. It's thought that K2-18b is one of these types of planets. The planet was originally discovered back in 2015. It's a little over twice the size of Earth, and the detection of water vapor in the atmosphere made it a prime candidate for JWST to study further once it was launched. And in late 2023, the results from the JWST were released showing biosignatures were in fact detected on the alien world. The data showed that there was methane within the atmosphere, which was exciting since this is considered a biosignature for life here on Earth. Additionally, methane doesn't survive in the atmosphere for longer than just a few hours due to it easily breaking down in solar radiation. So if the planet were to contain these levels of methane, that must mean that something is constantly replenishing it. The JWST also detected a presence of carbon dioxide in the atmosphere, which alone isn't particularly uncommon, but the presence of both CO2 and methane was a promising result. But the biggest shock within the results was the detection of DMS.
So this is dimethyl sulfide.
Yeah.
That's the important gas. And why is that gas so important?
It's important because on Earth, it is produced only from life, mainly from microorganisms in the Earth's oceans, and it has been known to be a robust biomarker if detected in planetary environments, and it had been predicted to be so. And we had been looking for it, and that's why it's super important.
This potential discovery of DMS is significant because it's not something that we find naturally occurring here on Earth. It's only produced by life. K2-18b orbits a red dwarf star, which the radiation from those types of stars is typically extremely hostile to life. But this planet both receives a similar amount of radiation as Earth and also resides in its star system's Goldilocks zone, a zone around a star where it isn't too hot or too cold, the temperature is just right for liquid water to exist. This means that K2-18b, assuming its atmosphere is stable, would have a similar temperature to Earth. However, since its atmosphere is primarily hydrogen, that would mean that its oceans would be a little warmer than our own here on Earth. And when you combine all these factors together, this makes K2-18b the best candidate for the discovery of alien life outside of our planet currently. But as promising as all of this sounds, there are major concerns with the initial JWST results that could ruin any chance of confirming alien life on the planet. There's two things that you can always count on when it comes to breakthrough scientific discoveries. One, there will be an endless number of publications on the internet jumping to conclusions. And two, there will be an equal amount of scientists trying to quickly disprove the discovery. And other astronomers, planetary scientists, and astrophysicists wasted absolutely no time trying to challenge Professor Nikku's interpretation of the JWST data. Now, while some clickbait articles will tell you otherwise, the reality is that the signatures of DMS within the atmosphere of K2-18b were quite low. So low, in fact, that many scientists were discounting the detections as insignificant or irrelevant. Now, to Professor Nikku's credit, he openly expresses that he is approaching these findings with extreme caution.
We are not very confident about it.
And it appears that he is right to do so. Over the last few months, researchers from the NASA Ames Research Center and the University of Washington have taken the K2-18b survey data from the JWST and applied it to multiple different models to try to explain the initial peculiar results. The first model described rocky planets with liquid oceans both with and without life. The second model described gaseous planets with, of course, the absence of life. And these two model sets produced some pretty interesting results. The first model found that it was unlikely that a planet of this size and atmospheric composition would host complex life. However, it also showed that it was unlikely to not host any life at all. This means that this model predicts a considerable possibility that microbial life would in fact exist on such a planet. And while we wouldn't find strange-looking or colossal animals swimming around in its oceans, microbial life is still life, and it would be the first detection of life outside of our planet, which of course got a lot of people excited. However, the second model showed that a lifeless gaseous planet would also fit the JWST data quite well. This model details that K2-18b might not be a Hicean planet at all. It could be a sub-Neptune planet, which is defined as a gas planet that is smaller than Neptune but larger in mass. Both models were able to explain the JWST findings of methane just as well, if not better, than Professor Nikku's initial interpretation of the data, suggesting that he found biosignatures for life on K2-18b. But in the end, none of the models perfectly fit the JWST data, so the potential for life on the planet was not ruled out. But even outside of those proposed models, there are other factors that could completely ruin any hopes for K2-18b hosting life. The detection of methane within the planet's atmosphere could also just point to it being a lava world. This could sufficiently explain all the biosignatures detected on the planet, of course aside from the DMS, which has led research teams to suggest that any future search for life on exoplanets would need to measure the planet's temperature first, as a molten world would completely discount any thought of habitability. But even on a molten surface planet, that still wouldn't explain the detection of DMS. Despite all the skepticism presented, if DMS is confirmed to be in the atmosphere, that keeps K2-18b at the very top of the list and our best shot at confirming life outside of Earth. And thankfully, we'll be finding out that answer very soon. Now, for those still holding out hope that life could exist on K2-18b, there is some good news. On April 26th of this year, the JWST set its sights on the potential Hicean planet once again to take an even longer and more detailed look at the planet. As for when we'll see these results, it could take several months, perhaps as long as 6 months from now. K2-18b has an orbital period of 33 days, so NASA wants to give JWST enough time to gather as much information as possible. Then, whenever the results come back, they will be scrutinized even more than the initial results. But let's just take an optimistic approach and say that the results show a definitive presence of DMS with an extremely high certainty rate. That will mean one of two things. Either this will suggest that DMS can occur without the presence of life and be produced by some other mechanism that we simply aren't aware of right now. The other is confirmation that life in some form or another exists elsewhere in the universe. We will no longer be alone. Of course, this news would stun the world. The implications of the discovery are massive on all levels, from scientific to philosophical to societal. It would change everything, and it would change the way that humanity sees itself and its place within the universe. And when these results are eventually released, at best if confirmed, it would be the most important discovery humanity has ever made. It would also cement the James Webb Telescope as unequivocally the most important scientific instrument humanity has ever created. But at worst, it determines that K2-18b simply isn't habitable, and the James Webb Telescope can set its sights to new areas in the universe to continue its search for life. Either way, while this is a very exciting time for space exploration, it's important to remember that extraordinary claims require extraordinary evidence. And just because Professor Nikku made a tantalizing discovery, that doesn't exclude him from that process. Now, the optimist in me hopes that he is 100% correct. I hope that we have found life somewhere else in the universe, but I have to be honest, I have real deep reservations about the validity of his claims. I don't have reason to believe that he's making intentional false claims. However, if he was, he wouldn't be the first. This is all a part of the trial and error of science. I know that it's so easy to get swept up in the headlines and overly excited, but if you follow the evidence, the answer will eventually reveal itself. In other words, focusing on the journey is more important than the destination, and humanity will never reach that destination if we stop looking.